Manifold distributes the air and fuel mixture to the engine's cylinders. Inside, a spark plug ignites the mix, setting off a combustion cycle which propels the vehicle. For optimal performance and efficiency, the manifold must distribute to all cylinders evenly. Whether in an engine with a carburetor like this one, or in a newer technology fuel-injected engine, the manifold's tubes, called intake runners, feed the fuel and air mixture to the engine cylinder heads. The manifold is made from long blocks of extruded aluminum. First, a computer-guided saw cuts each block to the required length. Metal cutting metal produces a lot of friction-generated heat. A steady stream of water-based coolant and lubricant prevents the saw blade from overheating and breaking down. A computer-guided machine shapes the block from multiple angles, transforming it into the rough form of one of the manifold's two sides, called banks. Later, this bank, which has 4 ports for runners, will be mated with the opposing bank, which has another 4 ports for runners. The machine now shapes the inside of the runner ports, which are curved and tapered in a very specific way. The banks come off the machine with some rough edges. A machinist smooths them out with a handheld grinder, a process called deburring. Once the banks are finished, they go on to a flow testing machine. It measures the airflow in cubic feet per minute in each port. To achieve maximum efficiency, each port must have the same amount of air moving through it at the same speed. The runners have been machined separately. A quality control technician runs a file over the runners and the banks to check for any imperfections. He then cleans all the surfaces with solvent. The aluminum must be free of any oils or other contaminants prior to welding. It's finally time to mate the 2 banks. Workers mount them on a mock-up engine in order to get the fit exact. Then temporarily bolt them down to hold their position. Now a welder takes over. Using a high-precision welding machine, he first tacks the banks to each other in a few spots to secure the positioning. Then he fully welds them together. Next, he attaches the intake runners to the ports. A light tap to make the tongue and groove connection, followed by welding along their perimeter. A manifold has 1 intake runner for each cylinder of the engine. This one's designed for a fuel-injected V8 engine. Therefore, it has 8 runners. Once all the runners are welded on, he closes up the manifold with front, back, and top panels. He welds these parts as well. Next, workers mount the fuel rails, which send fuel to the injectors. The injectors go on afterward. This is a high-performance manifold with a built-in nitrous oxide system. These are the stainless steel feed lines for it. Nitrous oxide is a compressed gas that's high in oxygen. It allows more fuel to be injected, which increases combustion pressure, giving the engine up to an additional 500 horsepower. They mount the throttle body through which air enters the engine. The pivoting brass blade in the center is an air metering device. The deeper the driver pushes the gas pedal, the more it opens, letting in more air. The injectors simultaneously shoot in more fuel. The result? More power. This sophisticated testing machine checks for leaks and measures several factors, such as the nitrous oxide flow. While the function is the same, the shape and configuration of intake manifolds vary according to the type of engine, in order to optimize performance and fuel efficiency.